Point 1, graphing exponential function. So let's go through this worksheet. So you want me to graph these functions and state the remainder range. So first thing I want to know is it grow for decay? Well, look right here, right? That b term, y equals abx. B's bigger than 1, so it's a growth. My a's number in front of that guy, the coefficient, so in this case it's 2. And then there's nothing out here. Right, if there's nothing out there, that'd be my horizontal asymptote. Since there's nothing, it's a 0. So I always like to start there, horizontal by 0. My a is 2, so I'm going to go 2 above that. That's going to be my initial y-intercept. And it's a growth. So remember, we're just doing a sketch here, so it's kind of like that. If you wanted like a more detailed graph, you can always make a table. Start at 0, 2, and then 1, and -1, and so on. Domain. So look at it. Farthest left, negative infinity. Farthest right, infinity. So negative infinity, or all row numbers. My range. Look at the lowest is right here at 0. The lowest it goes, right? Keep going straight. This is the asymptote. So 0. And then infinity. So 0 to infinity. Now you notice it's a bracket. It's a parenthesis, not a bracket, because you can't actually touch 0. There's asymptote there, so you're not going to go past it. So that's that first one. The second one, growth for decay. Now this is a little tricky. It's normally a growth because that b's bigger than 1, but there's a flip, and the flip always changes it. So like initially I would say growth. B's bigger than 1, but there's a flip right there, so it's actually a decay. You know, that makes more sense when we start graphing it. Horizontal asymptote plus 0 again. So y equals 0, I like to start there. Now flips are a little funky. So the way this one would work would be you cross that 2 normally. So let me try this in a different color. I'll do this in like red. Cross that 2 normally, and it's a growth, like I said, so it looks like this normally. That's what this guy looks like. But since it's a negative, it flips up. It's on the outside, it's a vertical flip. You're going to flip it up and down. So your graph's actually going to be hit at -2. And just be like this. And see, that's a decay, right? It's like you're going down. Like if that was your stock, that'd be sad. Domain, negative infinity, positive infinity. This is going to be the domain for like all these questions, by the way. And the range, what's the lowest? Negative infinity, all the way to 0, all the way to the asymptote. Negative infinity to 0. Next one. So what's growth for decay? No, there's no flip here, so that thing's bigger than 1, so growth. What's my a? Now a lot of people put 4. It's not 4. Remember, a is the number in front. It goes like this: a, b to the x. This is my b. My a is not there, so that makes it a 1, not a 0, because you're multiplying. If it's like a plus, then it's 0, but you're multiplying, so it's a 1. Horizontal asymptote right here, -5. So that's where I'd like to start. We're going to start at -5. My a is 1, so we're going to go 1 above that. I should have made it a solid line. Just make like a light line. Remember, that's your initial y-intercept, the 1. But then you got to move it left 1. So I'm actually going to be right here. And it's a growth graph, so you're just going to try to start there, hit that, and try to go up. Again, this is a sketch. That's what it looks like on a sketch. If you want like a nice answer, you can make a table. My domain, negative infinity, positive infinity, like all of them. My range, the lowest I see is -5, the horizontal asymptote, and then it goes all the way up to infinity. So there we go. Next one, another flip. So now this one initially is a decay actually. Like I would say this is a decay because it's less than 1, but there's a flip there. So it's actually at the end it's going to be a growth. But initially it's a decay though. So what's my a? My a is 4. And then my asymptote's at 3. So now here's the thing though. It's going to be a little funky. So the flip is the first thing you're supposed to do. So let's look at how a normal flip graph looks like. Let's look at this graph looks like before you flip it. So this would be, if I was just looking at everything else, if I was looking at just 4, 3/5, what would that look like? Well, you start here, you go up 4. And then it's a decay, so it goes down like this. That's what it normally looks like. So our graph, we're flipping it vertically. It's going to look kind of like this. So like, why don't you do it on the graph, on the actual graph? So I just want to know what the picture looks like. We still got to do all the flips and move. We still got to move it left and right, up and down. So that's what it's going to look like. It's going to look like this though. But it's going to be flipped. So it's going to be kind of like that. I guess I'll just do it on here. -4. Kind of like that. anyway, that's the picture. That's the most important part. The picture looks like this. Right? Normally a decay graph looks like this, but you're flipping it up and down, so it looks like this. That's the picture we're going to draw on this thing. Once I clean it up a little bit. So let's talk about this graph here then. My vertical horizontal is at 3, so 1, 2, 3 right there. Normally we go down 4, 1, 2, 3, 4 right here, and I gotta move it left 4 because of this inside opposite. So 1, 2, 3, 4. So like right here. So now, again, now it's just a decay graph since it looks like this picture here. So we're gonna go up, hit that, and kind of curve. That's what it looks like. Again, a little weird, but that's what it looks like. Domain, negative infinity, positive infinity. Range, look at this graph. Lowest is negative infinity, highest is 3. And there we go. Next one's application problem that we will need a calculator for, or plug it into like decimal thing. The function p of x equals 2.28 times 0.9 to the x can be used to model the number of payphones, remember those things, in millions of years since 1999. Classify the functions either exponential growth or decay, and identify the growth or decay factor, then graph the function. So look at the thing right here, right? It's all about a and b. A is my initial value, b is my growth or decay factor. This is less than 1, so it's a decay. The decay factor is 0.9. Note the px intercept and the asymptote represent in this situation. So what's basically the y-intercept, what's the asymptote represent in the situation. So if we look at the graph of this thing, oh, then graph the function. I didn't do that on the first one, hey! So graph the function of the first one. So how do I graph it? Well, we're graphing this. So how would I graph it? There's nothing here, so plus 0. My a is 2.2, so we'll go 2.2. And it's a decay function, so it's going to go like this and go down. Like that. Right? Number p uses the number of payphones. That's what p stands for. So this right here, my p of x, is the number of payphones. And this is my years. I guess it's x. So there we go. That's the graph. Again, this is a sketch. Explain what the px intercept, so the y-intercept is. So this is the initial amount. That's that guy. That's the initial amount of payphones. So that's what that is. And the asymptote represents. So the asymptote is this guy. So the asymptote represents that you're gonna. That's like the lower bound. You're never gonna have negative payphones. Not possible to have a negative amount of payphones. There we go. Next one, more graphing. So graph each one, take the remainder range. So let's go to the first one here. What's the A? The A is 2. Growth or decay. This is my B, and it's less than 1, so it's a decay function. Horizontal slope, we don't see anything there, so plus 0. And now let's graph it. So right, I always start the horizontal slope, 0. My A is 2, so that's next. Go 2 up. And then it's a decay function, it's less than 1, so it's going to go down, like it's decaying. So you kind of hit that, and then that's where you come on turn and not go past that line. So that's kind of our decay function. Again, we're just doing a sketch. Domain, negative infinity, positive infinity. All the graphs on this will have that. The range, lowest I see 0, highest I see is infinity. So there we go. Next one. My A, now again that's the B, the A is the number in front of that. You don't see it, so it's 1. Growth or decay, it's bigger than 1, so it's a growth. Or the asymptote, looks like it's 1. So let's graph this. We start with the asymptote at 1. My A is 1, so I'm going to go 1 above. But on this one, I got to watch out. That's not my starting point. So I go 1 up, but then I got to go 3 to the right. So I'm actually starting out like at 1, 3. But it's a little weird because the 1's not from this. It's from the fact that the asymptote, it's 1 away from the asymptote, and then 3 over. So I'm starting like right here. And then it is a growth function, so we're going to start low and climb up. So once you hit that point, that's when you start really going vertical. And I probably don't go vertical enough. It's probably supposed to be more like up there. But anyway, domain, negative infinity, positive infinity. And the range, lowest to highest. Lowest I see is 1 to infinity. So there we go. The next view. Another one. A, again, no number in front, so 1. That's a 2, so that's bigger than 1, so that's my growth. Horizontal slope's going to be at 1 again. And we just got to graph that. Search for asymptote. Go my A above that, so right here, there's no left or right. It's not like the last one, I got to move left or right, just start there. And then it's a growth. So go up. Should bend that more. Anyway, it should be a little bit more bent, but that's the idea. Domain, negative infinity, positive infinity. And the range, lowest I see here is 1 to infinity. Last one with graphing. So we gotta follow this stuff. No flips, luckily. A is the north front, so 2. Growth for decay. My B here is less than 1, so decay. Horizontal asymptote, that guy right there, negative 3. And we just gotta graph it. So go down your horizontal asymptote, negative 3. Put that line there. My A is 2, so I should go 2 above it. So I feel like my lines are not, that's a little off. That's like a negative 4. Let me fix that, it's gonna bug me. So right here, that's negative 3. Then I'm gonna go 2 above that, that's my negative 1. And then it's a growth for actually negative 1, but then I gotta move it left 2. So it's actually gonna be over here. Let me erase this point. Right, so go to asymptote. Then you have to go 2 above it because of the A. So 1, 2. And then you gotta move it 2 to the left because of horizontal flip shift. So right there. And it's a decay. So that means we're going to come down, hit that, and then curve. So something like this. And then from here, I want to start curving. And we don't want to go past the asymptote. So something like that effect. Domain, all row numbers, negative infinity, positive infinity. And then range, we're going to go from negative 3 all the way to infinity. Like that. A few more. A cup of tea contains 35 milligrams of caffeine. The average teen can eliminate approximately 12.5% of caffeine from their system per hour. I think they want me to come up with an equation. Okay, so I should have said that. Write an equation. Which means we're going to write like this. Right equals a b to the x, or more notably, y equals a 1 plus or minus r to the x, right? That's when we have an exponential equation. So we start with the 35 grams normally, so that's our a. Now remember the way we figure out what the b is, or this using this formula is, you start out 100%, and then you add or subtract. If you go up, you add. If you go down, you subtract. Average you can eliminate approximately 12.5, so we're subtracting 12.5%. So I guess it'll be like, this is like 100% minus 12.5. So 1 minus 0.125. These are both in percents. Right, you start with 100% or 1, and then you subtract off the percentage. And this should be 12. If we make 0.25%, it should be 0.125. Right, it's moved over the decimal a couple of spots. Since it's a percentage, you move it over a couple of spots, you get this. Subtract, you get 0.875. So that is my decay rate. So our equation would be y equals 35 times my decay rate, 0.875 to the x. I guess if I was putting into this equation, if I was starting there, it would have been sort of like this. 1 minus 0.125x. Like that. And that turns into this. So if you want to figure out how much coffee is in your system at any one time, you just plug in, after so many hours, you just plug it into the formula. Pretty cool. The first U.S. census was conducted in 1790. At that time, the population was 3,900,000. Since then, the population has grown by approximately 2.03% annually. Draw a graph showing the population growth. So first, I want to draw an equation. So our equation is this. We'll do the plus and minus R1. It's a little easier. So right, what's my initial value? This 3 blah blah blah. 1, now are we adding or subtracting? We're growing by 0.2, so it's 1 plus 0.203. We're going to make it a decimal, not a percent. So my equation is going to be this. Like that. So how would I graph it? Now again, since it's a sketch, what's my horizontal slope? I don't see it, so 0. Is it a growth or decay? It's a growth, so it's going to be going up. And my A is 39 million, blah, blah, blah. So wherever that is, that's going to be right there. Then we just go up. So we start down here, kind of hit that and go up. Something to that effect. That's the worksheet.